Hello everyone, welcome back to our AI engineering crash course. Today we'll talk about RAG, Retrieval Augmented Generation. So before that, we went through all of the concepts that you need to understand before building AI applications, like general concept about AI engineering, prompting, APIs with multiple providers, and also LLM frameworks. And in this module, we talk about embeddings, a vector store, semantic search and querying that we will be using in this video here. And in this video, we'll talk about retrieval augmented generation and chunking text. And in the next one, we will use the libraries that we introduced in the last module to implement retrieval augmented generation. So let's get started. From the last video, I mentioned that there were a lot of concepts here that we will need to come back to, okay? This is the time we need to come back to these concepts. So just let me introduce to you retrieval augmented generation and why it is an important concept with LLMs. Okay, so what happens is that we created LLMs, right? We created large language models in this, and this large language model can generate text extremely well, but it's not useful because it hallucinates. Okay, it means if you want to have real knowledge from the AI, you can get a lot of errors back and rely on these errors to take decisions, which would be not good for your company or for your use case, right? So they created something called retrieval augmented generation, which means you try to feed to the AI the context of what it should be considering while answering a specific question. It can be something like, okay, you have a document, an internal document about maybe some company policy document like this, and you want to add something specific to the AI, like, okay, how many sick leave do I have in this company, right? Without the context of this document, the AI will just answer randomly and give you a wrong number. But if you get a specific context, which means getting some chunk of this document, let's say something like this, this chunk talking about sick leaves, you'll be able to give that to the LLM, and then the LLM will use exactly this context to be able to answer back. And if the LLM finds nothing from this context, you will say, sorry, I don't have the answer. So it helps you reduce hallucination, and it created a really big new use case for AI, which is document question answering, working with knowledge base or company's knowledge base or company documents, which became really, really popular in 2024, last year. So in this video, I will just explain to you how we are able to go in a long document, get a single part of this document related to what you're asking for, feed it to the AI, and get a response that's actually accurate. Okay. So, and let's start with this thing here. So let's first say you are a company. Maybe you have a lot of documents. It can be videos, it can be on GitHub, on Drive, or whatever. And you want to be able to chat with these documents. The first thing you need to do is to connect all these documents to your app and load them in some kind of objects in your app. So that's possible with the set of tools that we have out there. You can actually connect to many data sources and pull data from these sources. When you have the data into your Python or TypeScript app, you can now transform this data and maybe separate them, which means, for example, you have here company policy, you have here contract, you have here maybe pay slips, and then you are able to chunk this single document into small pieces that may make sense to give to an AI. So in the company policy part, I think I mentioned it somewhere here, you need to chunk it as small part like this. First part, second part, and third part. And this part are actually made for to be small enough to be passed to an AI and to be large enough to have a meaning, right? So if you take two paragraphs of this text, for example, of your sick leave, it may be enough to be able to give a real answer about the question you're asking for. Same as taking 2 pages. But the problem here is you cannot go too far. You need to be specific in the number of pages. You need to be as short as possible in the number of characters you're taking, because the more context you give to the AI, the more extensive it became. And you also need to be as large as possible in the amount of value that you have in each single chunk, right? Okay, so you do this part here with chunking. And then what you do is you calculate the numerical representation of each of these single chunk of text that you created. We talk about embeddings, and what you may keep in mind is that in this document, chunks that have same meanings will have in the space where we can plot these vectors nearly the same location. So if you have vacancy policy and something closely related to it, they will nearly be at the same place. So you can give this data, this numerical representation, and the related document to a vector store. This vector store will keep them and internally have an algorithm that can calculate which document is close to what other document. And then you have the last part here called retrieve part. The retrieve part actually come when you start working with LLM and you want to retrieve a specific context for a specific question. And that comes to this part here. Okay. So let's start over again. You have a knowledge base, like a lot of documents. You get this document into your app using data connections. And then you chunk them into specific small set of text. Okay. This set of text are small enough to not be too much as a context to the AI, and big enough to have a certain meaning, so you can extract information from it. What you do is that you compute the embeddings of this chunk of documents, and you save them in a knowledge base as vector database, like a vector store. So now all of your documents with the related text is saved somewhere. Now, when the user come in and say, okay, how many sick leave do I have in this company? The AI will get the query, okay? Create the embedding of this query, which means the numerical representation of this text. And as I mentioned before, texts that are close enough will have, texts that are close in meaning will have a small distance in the space, okay? In the space when we plot all these numbers in some kind of space. So when you compute the embeddings, the distance between the embedding of the query of the user and the text that you have, the documents that are closer to this embedding here are actually the one that may have the meaning or the information you're looking for, right? And you extract this data. You maybe choose 5 of them, top K similar document. So this is called similarity search. I think we talked about it in the last video. Where you actually extract documents that are similar to the user query, and you give this document as a context to your large language model. And at the same time, you say to the large language model that if you don't find any information from my context, just say you don't know, okay? And you feed it the user query as well. So the LLM now knows, okay, this user is asking about sick leave, the amount of sick leave he can actually benefit from the company. And we have this set of K documents, 3, 5, 6, 10, depending on you and the budget that you have, that may mention it, okay? If the AI is actually able to find some information in the context that you gave, that you extracted here, which is actually some part of the documents of your internal company policy, for example, it will say, oh, okay, this is the answer. We have 21 or 10 sick leave days, okay? And it will give back the answer to the user. So that's basically retrieval augmented generation. So retrieval is for this part where we retrieve the data from a vector store. Augmented is to augment the context to our LLM, and generation is to generate a response and give it back to the user. Okay. So now, in the haystack example, in the framework videos in the last module, we went through all this. We had generators, embedders, retrievers, converters. I think you should be able to understand some part of this picture here, with the generator just being LLMs, the embedders just being the algorithm or the models that actually compute the numerical representation of this chunk of text. So we have OpenAI, Azure, Hugging Face, and many other providers, Google and Anthropic and others. Now we have retrievers. So these are actually vector store. Okay. So when we compute this with embedders, we feed them to the vector store. So it's just like a database. And this database contains two different information: the embeddings, which is the numerical representation of the text, and the text itself. And when you get a document or a query, you go there and you're like, oh, give me the closest document to this, or the closest text that resemble what the user is asking for. And when you get back this, you can directly feed it to an AI. Okay. So here, for example, we have a pipeline, an haystack pipeline that actually does what we are explaining. We have some query here. We suppose that you already created a vector store with all your documents. Okay. And then from the query, we create the embeddings using one of these embedding model. And the next step on the pipeline is actually just comparing these embeddings to what we have in our vector store. Query embedding, and we get back some documents. We create the prompt with these documents, and we feed it to the LLM. The LLM just generate a response, and we give back the response to the AI. Same for Llama Index here. So in general, when we talk about RAG, it means we have a set of documents that we created, that we integrate into our app. We chunk this document. We create embeddings based on this document. We save it in the vector store. Okay. And when someone asks something, we go in this vector store and retrieve all the documents that are really close to what the user is asking for. And we get this document, we give it to the LLM as context. And the LLM generates a response that may be more true than just straight LLM knowledge. Okay. And as you can see, many of these frameworks are actually built around the same concept. Llama Index is purely built on top of manipulations of documents. Haystack pipeline are really optimal when you work with documents. And as you see here in LangChain tools, you have vector stores. Now you should understand what vector store means. Text splitters to split text, this long document into small text. This framework already gives you all the results or the tools that you need to do everything we explained here. So you don't have to think about, oh, how do I compute the numerical representation of a text? How do I transform this text? How do I chunk them? How do I store them? How do I calculate the distance? All of that is actually handled by this framework. So if you choose LangChain, Haystack, or Llama Index, you will be able to get the same result at the end, which means having connectors to pull data from different sources. So you don't have to worry about that. Having chunking or text splitter to split these documents into chunks. Having a vector store to be able to calculate embeddings and embed this and save it into the vector stores. Having where is it again? Sorry. Having here retriever from this vector store. Having also an LLM modules where you can just feed this context to the LLM and get a response back. Okay. So with that said, I think the general concept around RAG is actually what I just explained here. In the next part of the video, I will give you a real overview of the whole process here. We'll not be talking about rankers or routings or much more complex topics. I will do a separate serial video about RAG and how you can get the most out of it with augmenting accuracy, making sure you always pick the right context or the right document in the database, and many other concepts that we'll not be talking about here. I will also put a video in the description from LangChain, giving you a deeper knowledge about RAG using LangChain. So yeah, thank you for watching, and see you in the next video.